So this is the third class in a series of Laplace Transform classes that I'm taking on YouTube. So in this series of lectures on Laplace Transform, I'm covering the basics as and when required, and I'm solving the previous year questions of GATE. Fine. So in this part, we'll talk about, we'll deal with problems on inverse Laplace transform, and unilateral Laplace transform. So these two model of problems, the previous year questions based on these two topics we will cover. I'll give you the basics of inverse Laplace transform and unilateral Laplace transform as well. So let us go into the topic. So here they're asking us to find the inverse Laplace transform. So here I'll solve this question in such a manner that you'll be able to answer other inverse Laplace transform questions as well. Right. So the first thing that you should do when you're asked to find inverse Laplace transform is first find the partial fractions. Find the partial fractions. X of s is equal to, so write it as s plus 1 plus s plus 3. You might have learned how to find partial fractions very well in your mathematics. So you can use all your efficiency to find the partial fractions very quickly. Because the quicker you find the partial fractions, the quicker you find the inverse Laplace transform. Similarly, when you're trying to find inverse Z transforms also, partial fractions, having the knowledge of partial fractions and able to do the partial fractions quickly is going to be an added advantage. So whenever you want to find inverse Laplace transform or inverse Z transform, partial fractions, the basics are compulsory. So learn partial fractions and how to find it fastly. Right, now let us find the partial fractions. So s equal to minus 1, if you substitute, it will be 2. 4 by 2 is 2. And s plus 3, if you substitute 3, substitute minus 3 here. Minus 3 plus 1 is minus 2. Minus 3 plus 5 is 2. 2 divided by 2, which is minus 1. Yeah, correct. So this is the Laplace transform expressed in terms of partial fractions. Now, I'll talk about the answer in a general format. Okay, I'll talk about the answer in a general format. Right. So the Laplace transform of e power minus at into u of t signal. Laplace transform is 1 divided by s plus a, where the ROC is a real part of s greater than a real part of minus a, because minus a is the pole here. Similarly, if it is e power minus at into u of minus t, or else minus u of minus t if you take, the Laplace transform of this signal is also exactly 1 by s plus. But the ROC here is different. So ROC is a real part of s less than a real part of minus a. So when anybody asks us to find the inverse Laplace transform of 1 by s plus a, it can be this signal or it can be this signal also. So only thing is, when is the inverse Laplace transform different? When the ROC is different, then the inverse Laplace transform is also different. Let me ask you the same question in a different way. Find the inverse Laplace transform of 1 by s plus a. Same function, Laplace transform function is same for two different signals. For two different signals with same poles, minus a, minus a, same poles here. One is right-sided signal, another one is left-sided signal with same poles. So Laplace transform of function is same, but the inverse Laplace transform is not unique if ROC is not mentioned. If ROC is mentioned, then inverse Laplace transform is unique. If they have given 1 by s plus a with this ROC, then inverse Laplace transform is e power minus at into u of t. Whereas if they mention this ROC, same function, the inverse Laplace transform is different. So the answer is, so the pole here is minus a. If the pole is minus a, the function corresponding to it is e power minus at. E power minus at is the basic inverse Laplace transform. What is multiplied to it? Is it u of t or minus u of minus t? That depends on the ROC. So the answer is e power minus at multiplied with u of t if ROC is real part of s greater than real part of minus a. Similarly, instead of u of t, replace it with minus u of minus t if the ROC is real part of s less than a real part of minus a. Okay, right. So understand it carefully. right? Now, so this ROC, when they're asking to find the inverse Laplace transform, generally they'll be giving the ROC directly, or the same ROC they might mention it indirectly also. How are they going to mention indirectly or directly? So instead of saying this ROC, they might say that it is a causal signal. For causal signal, ROC is right-sided. Okay, when they give a right-sided ROC, you should understand that okay, they're talking about a causal signal. Okay, so in the inverse Laplace transform, the basic answer is e power minus at because the pole is minus a. It should be multiplied with u of t because we have recognized that it's a causal signal, or they have given us that it is a causal signal. Similarly, this will be the inverse Laplace transform when this is the ROC. Instead of giving this ROC, they might give information which corresponds to this ROC, like anti-causal signal they might say, or left-sided signal they might say. Okay, like that they'll give some hint or information for us to recognize what ROC they are talking about. So most probably they'll not give us the ROC exactly, but they'll give us a hint about the ROC. From the hint, we should understand what ROC they are talking about. Once we understand what ROC they are talking about, it's easy to find the inverse Laplace transform, right? Fine. Now, just follow the procedure that I'm doing. So you can apply the same procedure for any inverse Laplace transform problem, right? X of t is equal to 2 into 1 by s plus 1. 1 by s plus 1 will be the Laplace transform if the pole here is minus 1. So the signal, time domain signal corresponding to this Laplace transform function is e power minus 1 into t, because minus 1 is the pole, right? And is it multiplied with u of t or minus u of minus t? That we are not sure. Next step, here it is minus 1 multiplied with the function corresponding to s plus 3. 1 by s plus 3 is e power minus 3, because the pole is minus 3. Next step, is this multiplied with u of t or minus u of minus t? That we are not sure. Okay, so we can fill these two gaps if ROC is mentioned. Okay, and whenever ROC is not mentioned, here they are saying, asking us to find inverse Laplace transform, and they have not given any extra information. They have not given us any extra information. If they have not given any extra information, you can assume that it's a causal Laplace transform. They are talking about causal signal. Whenever no information is given about the signal or about the ROC, you can assume it is a causal signal, which means ROC will be right-sided. Okay, so this is the basic answer. What are the possible answers? So if you look at this problem, there are two poles here. So corresponding to two poles, there will be, one second, whenever you are doing inverse Laplace transform question, if you want to understand how many ROCs are possible, it's better if you plot the S-plane. Take S-plane and plot the poles. What are the poles? Minus 1 and minus 3. Minus 1 is one pole, minus 3 is another pole. Always, whenever you are plotting the poles in S-plane, draw vertical lines passing through the poles. Vertical lines are really important in S-plane. Vertical lines passing through the poles. Now tell me, how many regions can you form, continuous regions can you form in such a manner that there does not include poles. So if you look at this region, this is the first region, which corresponds to real part of s greater than minus 1 or sigma greater than minus 1. And this is second region, where the ROC is like sigma less than minus 3. Starting from minus 3 till minus infinity. This is the total region, which does not include any pole. This is one possible ROC. And one more ROC is also possible, minus 3 less than sigma less than minus 1. Instead of real part of s, you can write sigma also. So this is third ROC possible. There are three ROCs possible, which means there are three possible inverse Laplace transforms. Which means for this one, basically there are three answers, three different answers. But since no information is given, we can assume it is causal and we can do the problem. But anyway, let us do the problem in a general way. So there are three answers here. Because for three different ROCs, there will be three answers. The first answer will be for the first ROC, sigma greater than minus 1. Second answer will be for the second ROC, which is sigma less than minus 3. Third ROC will be for the third ROC, which is minus 3 less than sigma less than minus 1. Right. First, let me copy the basic answer. In all three cases. Observe it carefully. Now, so since you're talking about sigma greater than -1, if this ROC is given, it means it means um, you're talking about a right-sided signal because ROC is right-sided. Right-sided ROC corresponds to only right-sided signal. So the time domain signal is a properly right-sided signal, definitely, because ROC is right-sided. So which means you should be having U of t. You should be having only U of t. There should never be U of minus t for right-sided ROC, because if there is U of minus t, then ROC cannot be right-sided. So that's why both places in the basic answer fill U of t everywhere. For every pole, the signal corresponding to every pole should be multiplied with U of t whenever you're talking about a causal ROC or a right-sided ROC. There will be only one right-sided ROC. If you plot S-plane and if you plot the poles and figure out the ROC is possible, there will be only one right-side ROC, one left-side ROC, and there might be, depending on the number of poles, there might be one rectangular strip ROC or multiple rectangular strip ROCs also. Since there are two poles, only three ROCs are possible. If there are five poles, there might be more number of ROCs. So which means one ROC will be a causal ROC, which is right side ROC, one ROC will be left side ROC, and the remaining ROCs will be, there will be rectangular strip ROCs. Right, next, sigma less than -3, this ROC, the second ROC. Sigma less than -3 corresponds to left-sided ROC. So you'll get left-sided ROC only if you are talking about a left-sided signal, which means in the basic answer, fill the gaps with minus U of minus t. Minus U of minus t. Fill the gaps with minus U of minus t. If it is minus, then it will become plus. Very simple to find the inverse Laplace transform whenever the ROC is right-sided or left-sided. Because it's very simple, either you fill with U of t's or you fill with minus U of minus t's. But whenever the ROC is like in between the two poles, or it's a rectangular strip of ROC, okay, where both ends, both endpoints are poles, in that case, the problem becomes little tricky. Here we have to be little bit careful. Just follow the process that I'm doing. Here the pole is -1. Whenever the pole is -1, if you're talking about only this signal, e power minus t signal, if you're talking about only this signal, e power minus t signal, the ROC can be sigma greater than -1, or it can be sigma less than -1 also, based on whether it is U of t here or U of minus t here. If it is U of t, the ROC will be sigma greater than -1. If it is U of minus t here, then it will be sigma less than -1. Correct? Next, coming to -3 pole, the ROC corresponding to this signal is sigma greater than -3 or sigma less than -3. Based on if U of t is present here beside my power -3t, then ROC will be first one, sigma greater than -3. Then if it is U of minus t present beside e power -3t, then the ROC is sigma less than -3. Right? We don't know. According to corresponding to this pole, there are two ROCs possible based on what is multiplied beside this. And similarly for -1 pole also, there are two possible ROCs based on what is multiplied to e power -t, U of t or U of minus t. Now, but the final ROC, how do we get the final ROC? When you're talking about the summation of two signals, the ROCs will get intersected. So which means this ROC, the ROC among these two, one among these two ROCs and one among these two ROCs are getting intersected, and we are getting this ROC as final ROC. Okay, here we are trying to use linearity property. If you are adding two signals, the Laplace transforms also will get, corresponding Laplace transforms also will get added, and ROC will be intersection of individual ROCs. Right. So now -3 less than sigma less than -1. This ROC we got because of intersection of one of these two and one of these two. Right. So tell me which among these two could have been intersected with one of these two to get this ROC, or other way of telling it is which among these two is having intersection with this. Which among these two is having intersection with this? Sigma greater than -1 does not have intersection. Sigma less than -1, yes, it is having intersection with this. The first one is not having intersection. Second one is having intersection. Which means, so if this was involved in the intersection, then only we get this ROC. If this was involved in the intersection of this ROC and the other one of these two ROCs, we will not get this. If this is involved in the intersection, we should not get this answer. So definitely this is the ROC corresponding to the pole -1. So if sigma less than -1 corresponds to left-sided ROC. So this pole -1 corresponds to left-sided signal. So what should be multiplied here? Minus U of minus t should be multiplied. Okay. Next, e power -3t. So -3 less than sigma less than -1. For this ROC, which among these two ROCs have intersection? Sigma greater than -3 is having intersection, whereas sigma less than -3 is not having intersection. If your sigma greater than -3 is the ROC, then if this one is intersected with this one, we get this ROC. If this one, the bottom one was involved in the intersection, then we'll never get this ROC, right? So sigma greater than minus 3 is having intersection with this ROC, and hence so this is the ROC corresponding to minus 3 pole. So this is the right-sided ROC, which means minus 3 pole corresponds to right-sided signal. So multiply U of t here. So for minus 1 pole and minus 3 pole. So we're just trying to figure out, based on the final ROC, we're trying to figure out what is the ROC correspond to minus 1 pole and what is the ROC correspond to minus 3 pole. So just write the ROCs possible for minus 1 pole and write the ROCs correspond to minus 3 pole, and then tick one of them as the ROC responsible for this ROC. Or, so once you write the two ROCs possible for the poles, so among those two, one of them will have intersection with the final ROC. So tick them. So whatever ROC is having intersection with this one, that is the correct ROC. Okay, so based on the ROC that we have selected for that pole, so multiply U of t or minus U of minus t accordingly. Okay, so this is the final answer. If the ROC is minus 3 less than sigma less than minus 1. For right-sided signal, no confusion. For left-sided ROC, for right-sided signal or right-sided ROC, no confusion. For left-sided signal also, no confusion. But if it is a two-sided signal or if it is a non-causal signal, if it is a signal which exists for positive time as well as negative time, which means one of the signals should have been U of t and other signals should be having U of minus t as well. Which one should be multiplied with U of t in the basic answer and which one should be having U of minus t, that is what we have to figure out. So here we have to do a little bit of analysis what I've done previously. Just go through it once again if you have not understood. So once you understood, it will be very easy. So if you can follow this procedure to solve the problem without remembering anything. Okay, so there are procedures where I can tell you easiest way to remember also, but you might forget when it comes to exam. So that's why I'm going with a very basic procedure. You follow this one. Right, now these are the three possible answers based on the question given. Since they have not given any extra information about ROC, so we can assume that it is a causal signal. If you assume that it is a causal signal, this is the answer in the present problem. But they can ask you a different question based on the same Laplace transform. Right. So finally the answer, let us take the answer in this case. It should be 2 into e power minus t minus e power minus 3t. So this is the answer. So whenever they have not given ROC, we have to assume that it is a unilateral Laplace transform. For unilateral Laplace transform, the default assumption is that it is a causal signal. And ROC is also always right-sided. So that's why they don't mention ROC for unilateral Laplace transform. So whenever they don't mention ROC, you assume that it is unilateral Laplace transform is given and it is a causal signal. So since it is causal signal, by default assumption is causal signal, they don't multiply U of t also. Okay, because by default we're going to assume that it is causal signal. Right. So this is the answer. But the exact answer according to bilateral Laplace transform is this one. This is the best way to write. But when they are talking about unilateral Laplace transform, there is no need to multiply U of t. We'll understand about unilateral Laplace transform a little later. Fine. So let us do the next question using the same basics that we have used now. Right. So 5 minus s. Let us write the Laplace transform by using factorization in the denominator. In the previous problem, they have directly factorized and given. In the present problem, they have not factorized. Let us factorize it. So shall we write it as s minus 2 into s plus 1. Is that okay? S square minus 2s plus s. Yes, that is fine. Now we can do partial fractions as we have discussed earlier. S minus 2, s minus 1. So if you substitute s equal to 2, it is 3. 3 by 3 is 1. And if you substitute s equal to minus 1 here, minus 3 and 6, minus 3 and 6, it is minus 2. It should be minus 2. Right? So here they have given some information. If the Fourier transform of the signal exists, they have given some information about the ROC. Okay. So they have given some information. They did not say the ROC directly, but they have given the information about ROC. Right. So this is the Laplace transform. So in partial fraction format, if it is in partial fraction format, it will be easy for us to find the inverse Laplace transform. So let us write the basic answer of inverse Laplace transform. The pole here is 2. So the signal corresponding to it is e power 2t. That is the basic answer. What is multiplied with it? That we don't know. And based on the ROC, we can understand what is multiplied with it exactly. First, let me write the basic answer. It is minus 2 into, what is the basic answer correspond to 1 by s plus 1? It is e power minus t. Minus t. So it can be u of t or u of minus t that can be multiplied here, right? So let us write all the possible answers here. So if you take s plane, so s equal to minus 1 is one pole and s equal to 2 is another pole. So this is the line draw vertical lines passing through the poles. So zeros zeros does not matter for us. Zeros will not involve in the deciding the ROC. So we don't need to plot zeros when you are understanding about ROCs. If you want, you can plot also, but zeros will not change the ROCs or affect the ROCs. So there are three ROCs possible. One is sigma greater than 2, and second ROC is sigma less than minus 1. Third ROC is region from minus 1 to 2. There are three ROCs possible. Now let us write the answers. X of t, if ROC is sigma greater than 2, if ROC is sigma greater than 2, it's a right-sided ROC. The signal will be, take the basic answer and multiply with u of t. As simple as that. I'm writing all possible inverse Laplace transform because I want you to understand all possible cases here, not just this problem. Next, similarly, x of t is equal to, what if ROC is sigma less than minus 1? If you're talking about a left-sided ROC, then the answer would be e power 2t into minus u of minus t into minus u of minus t plus 2 into e power minus t into u of minus t. I'm substituting here minus u of minus t. Minus into minus will become plus, and this will be the answer. So this is the answer for if the ROC is a left-sided ROC, or if they are talking about an anti-causal signal. If they have given the information as anti-causal signal or left-sided signal, then this would have been the answer. If they have given it as a causal signal or right-sided signal, then we could have picked the first answer as the answer for this problem. But they have not given that. They have given the information differently. But anyway, let us find the third answer as well. What is the ROC here? Minus 1 less than sigma less than 2. This is the ROC. So this is the ROC. Let me write the basic answer. E power 2t minus 2 into e power minus t. Okay, right. So the ROC corresponds to this pole 2. Here the pole is 2. The signal corresponding to this pole 2 has ROCs. If there is only this signal, the ROC is possible are sigma greater than 2 and sigma less than 2. And the ROC corresponding to this pole minus 1 or this signal e power minus t are sigma greater than minus 1 and sigma less than minus 1 based on what is multiplied beside u e power minus t. Whether it is u of t multiplied, then this is the ROC. If it is u of minus t multiplied, then sigma less than minus 1 will be the ROC. So these are the two possible ROCs. Why are we writing two possible ROCs? Because we don't know what is being multiplied to this one beside it. So if we know what is multiplied, then we know the exact ROC. Since we don't know what is multiplied, we are writing two possible ROCs. We have our target is now to figure out what is being multiplied to this signal and this signal. Okay, so by intersecting one of these two ROCs with one of these two ROCs, we got this ROC. So now one of these two ROCs will be having intersection with this. One of these two ROCs will have intersection with this, because one of these two and one of these two is being intersected to get this ROC finally, right? So tell me this one. So among these two ROCs, which among these two ROCs is having intersection with this? Minus 1 to 2. Sigma less than 2. Sigma less than 2 means minus infinity to values. Minus infinity to 2 values. They have intersection with this, right? Sigma greater than 2 means 2 to infinity. They don't have intersection with this. So this is not having intersection. This is having intersection. So sigma less than 2. So it's a left-sided ROC, which means the pole 2 corresponds to left-sided signal. So multiply it with minus u of minus t. Next, which among these two ROCs is having intersection with this one? Sigma greater than minus 1, yes. Sigma less than minus 1, no intersection. So it's a right-sided ROC. What should be multiplied? U of t should be multiplied. Since only two poles are there, if one of them is u of minus t, then you can understand that other one should be multiplied with u of t, because it's a two-sided signal, right? One u of t is there means another u of minus t should be there. If first one was u of t, second one we can understand that it should be minus u of minus t. We don't need to figure out also. But if you figure out also, you'll end up at the same answer. Fine. So we got the answers. Fine. Now tell me this. So if the Fourier transform of the signal exists, what does it mean? If the Fourier transform of the signal exists, we can say that signal is absolutely integral. If mod x of t dt, integration from minus infinity to plus infinity, mod x of t dt, if it is less than infinity, or if the signal x of t is absolutely integrable, this is what is the definition of absolute integrability. If x of t is absolutely integrable, it satisfies this condition. If it is absolutely integrable, or if it satisfies this condition, we can say that the Fourier transform of the signal exists and well defined also, they should say. Perfectly speaking, they should also have said well defined. Right. So whenever a signal is having a well defined Fourier transform, we can say that it is absolutely integrable. For all absolutely integrable signals, for all absolutely, AI means absolutely integrable. For all absolutely integrable signals, ROC of Laplace transform includes j omega axis or sigma equal to 0 line. Right. So look at this one, sigma greater than 2. This ROC does not include j omega axis. Sigma less than minus 1 does not include j omega axis. Minus 1 to 2 ROC, this ROC is including j omega axis. Which means when they're saying Fourier transform of the signal exists, they are giving us information about an ROC which is including j omega axis. So there will be only one ROC which includes j omega axis, and that is this ROC, the third one. So which means indirectly they are giving us the ROC is minus 1 less than sigma less than 2. That is the ROC. They'll give us some information. From that information, we have to understand one of the. They'll give us information only about one of the ROCs. We have to figure out that one ROC. Once we figure out that ROC, we know how to find the inverse Laplace transform for all possible ROCs. As I've discussed in the previous problem and the present problem, you can find the inverse Laplace transform for all possible ROCs. But from the given information, we have to figure out what ROC they are talking about. In this case, they are talking about minus 1 less than sigma less than 2 ROC, which means third case. So when you are doing the problem, you don't need to do, you don't need to find the answers for all possible ROCs. You don't need to do that. So once you figure out from the information they have given, once you figure out what ROC they are talking about, take that ROC and find the basic answer, and from the basic answer, find the inverse Laplace transform only for that particular ROC which they are asking in the problem. You don't need to find all of them. For you to understand, I'm finding all possible answers. Okay, right. So with this, we've covered the problems on inverse Laplace transform. So any other problem on inverse Laplace transform, you just do it in the same procedure. Okay, fine. So what is the answer now? So minus e power of 2t into u of minus t minus 2 into e power minus t. Yeah, the answer is third one. Right. Coming to the next one, which one of the following is the unilateral Laplace transform of g of t equal to t into f of t? Yeah, here unilateral Laplace transform or bilateral Laplace transforms properties are pretty much similar, except differentiation property, and integration property. Apart from that, every other property is same. So here they are talking about unilateral Laplace transform, but still the property that they are expecting us to use is multiplication by t property. Let me recollect that property. If a signal x of t has a Laplace transform of x of s with an ROC R1, let's say, then if a signal is multiplied with t, then what happens to the Laplace transform? It is minus d by ds of x of s. ROC will not change because of differentiation. The location of the poles will not change. The number of poles may increase, but the location of the poles will not change, and hence ROC will not change. Similarly, you can do it for t square also. You can apply for any power of t. Then you just differentiate it once again and apply minus. It will be minus 1 whole square into d by ds of d square by ds of x of s. Similarly, you can do it, multiply t again, one more minus, once again differentiation. The ROC will not change. Apply the same property. F of t Laplace transform, we know unilateral Laplace transform. 1 by s square plus s plus 1. Now t into f of t Laplace transform is minus d by ds of 1 by s square plus s plus 1, which is equal to minus. So we can look at it as s square plus s plus 1 whole power minus 1. So it is minus 1 divided by s square plus s plus 1 whole square into differentiation of this inside part is 2s plus 1 plus 0. So this minus and this minus becomes a plus. So it is 2s plus 1 divided by s square plus s plus 1 whole square. So this is the answer. Okay. Right. So it's an easy property to apply. Next. So in this case also they're talking about one-sided Laplace transform. One-sided Laplace transform means unilateral Laplace transform only. So first let me recollect some basics about unilateral Laplace transform. I'll tell you a very simple technique here. So if you know bilateral Laplace transform, it's as good as knowing unilateral Laplace transform. From bilateral Laplace transform also you can find unilateral Laplace transform. Let me tell you those basics. Unilateral Laplace transform, or in short we can also call it as ULT. So unilateral Laplace transform of x of t, signal x of t. The formula is given as integration from 0 to infinity x of t into e power minus st dt. This is the formula for unilateral Laplace transform. I'll write the formula for bilateral Laplace transform as well, then you'll understand the difference between them. So bilateral Laplace transform formula, same formula, but limits are from minus infinity to plus infinity. So you are evaluating this function for the time from minus infinity to plus infinity for all time in bilateral Laplace transform. Whereas in unilateral Laplace transform, you are evaluating it only for positive time. Right. So if you observe the relation between them, we can establish a relation between them easily. How about bilateral Laplace transform of x of t into u of t? If you multiply the signal with u of t, which means you are limiting the signal only for positive time. You are removing the negative part of the signal, negative time part of the signal, not negative amplitude part, negative time part of the signal. So it is minus infinity to plus infinity. Same formula I am applying, but the formula should be applied on x of t into u of t into e power minus st dt, which is equal to. So the equation of u of t is 1 for limits from 0 to infinity. For limits from minus infinity to 0, for the remaining limits, equation of u of t is 0. So we can change the limits as 0 to infinity. If you look at this one, if you look at this function, this formula, it looks exactly same as unilateral Laplace transform formula. So this is same as unilateral Laplace transform of x of t. So we have established a relation between unilateral Laplace transform and bilateral Laplace transform. So if you want to find unilateral Laplace transform of a signal x of t, then what you can do? First, multiply the signal with the u of t and just find bilateral Laplace transform, as simple as that. If you know bilateral Laplace transforms well, then multiply the signal which you are supposed to find unilateral Laplace transform. So multiply the signal with u of t and find bilateral Laplace transform if you know how to find bilateral Laplace transforms well. Right. So this is the relation. Using this relation, you can find unilateral Laplace transform of any signal without any confusion. Okay. Fine. Here they're asking us to find the Laplace transform of integration of a signal. Okay. Here I'll just recollect some basics. Let's say there is a signal x of t whose bilateral Laplace transform is capital X of s, whose ROC is R1. Next, what if the signal is integrated from minus infinity to t? Then what happens to the bilateral Laplace transform? It's very easy to evaluate this bilateral Laplace transform. You can also call it as integration property of bilateral Laplace transform. So whenever there is an integration, you can express the signal always as x of t convolution with u of t, because always you can imagine whenever you are talking about an integrator. So if there is a signal x of t, output of integrator is integration from minus infinity to t x of tau t. Okay. Now if you apply impulse as input to the integrator, what will be the output? Minus infinity to t del of tau d tau. And what is the output exactly here? U of t. So for impulse input, the response is u of t, which means the impulse response of an integrator is u of t. Okay, so which means this output, the output of a system, or the output of any LTA system, can be written as x of t input convolution with the impulse response, which is u of t. Okay, this result and this result are exactly same. So whenever you find convolution with u of t, you can write as x of t being integrated from minus infinity to t. Or whenever you are seeing a signal to be integrated from minus infinity to t, you can express that signal as x of t convolution with u of t according to the convenience. Here my convenience is, I'm writing it as, I'm looking at it as integration. Okay, you can understand it as, you can imagine the signal as, okay, x of t is being passed through an integrator. Okay, output of integrator is, okay, x of t convolution with u of t, you can imagine. Or you can also understand it like this also. So it's better to understand it that like this, so then it will be easy to understand the Laplace transform property. X of t Laplace transform is x of s, and convolution becomes multiplication. U of t Laplace transform is 1 by s. What will be the ROC? The ROC of x of s is R1, and ROC of u of t is what? Sigma greater than 0, or real part of s greater than 0. In convolution property, what happens to the ROC? ROC will be intersection of individual ROCs. It will be R1 intersection real part of s greater than 0. So finally answer is x of s divided by s. ROC is R1 intersection a real part of s greater than 0. So this is a bilateral Laplace transform property. Similarly, x of t, let's say unilateral Laplace transform property is x of s. There is no need to mention ROC for unilateral Laplace transform, because when you're trying to find unilateral Laplace transform, you are evaluating the signal only for positive time. So obviously the ROC will be right side ROC. That's why we generally don't mention ROC whenever we are talking about unilateral Laplace transform. There is nothing wrong in mentioning it, because by default it will be right side ROC. That's why generally we don't mention ROC for unilateral Laplace transforms. So integration from 0 to t x of tau d tau. Here we cannot apply this basic here. We cannot apply unilateral Laplace transform property. Here will be x of s divided by s, whereas integration from minus infinity to t x of tau d tau. If somebody is asking about this property in unilateral Laplace transform, not in bilateral Laplace transform. In bilateral Laplace transform, we know the answer. But in unilateral Laplace transform, that's not the story. The answer will be a little different. It will be plus integration from minus infinity to 0 x of tau d tau divided by s. We can write like this. And this is the answer exactly when signal is being integrated from minus infinity to small t. Unilateral Laplace transform and bilateral Laplace transform properties are completely different. You have to note this. You have to understand this carefully. Now I'll prove this one. So why should I remember? If at all if you forget, you should be able to derive it. Okay. Anyway, let us derive it quickly. X of t unilateral Laplace transform. Let's say it is x of s. What is the formula for this? Integration from 0 to infinity x of t to e power minus st dt. Now what are we supposed to find? Laplace transform of integration from 0 to t x of tau d tau. Sorry, minus infinity to t x of tau d tau, right? We can prove this property also actually. X of tau d tau. This property also we can find. So unilateral Laplace transform is equal to, the formula is integration from 0 to infinity. So whatever signal we want to find the unilateral Laplace transform, substitute that signal in place of x of t. into e power minus st dt. Look at this one. In place of x of t, I'm substituting this signal, integration of x of tau d tau, because we're supposed to find the Laplace transform of this signal. Whatever signal you are supposed to find Laplace transform, you substitute that signal in the unilateral Laplace transform formula, right? Now imagine this signal as a first part and this is the second part. You can use integration by parts. And it will be integration from 0 to t. First part I'm writing it as it is, and the second part we are integrating e power minus st divided by minus s, limits from 0 to infinity minus. Next, first part is differentiated, second part is integrated, or else integration from 0 to infinity. First part is being differentiated. If you differentiate this part, what we get is we get x of tau only, x of t, because upper limit is t. After the it will be x of t. Differentiation of this becomes x of t, and the second part is integrated once, e power minus st divided by minus s dt. Okay, now look at this one. If you substitute infinity, integration from 0 to infinity, x of tau d tau, wherever t is there, substitute with infinity for upper limit, e power minus s times infinity divided by minus s minus integration from 0 to lower limit is 0, in place of t substitute 0, x of tau d tau into e power minus s into 0 divided by minus s minus. If you look at this one, it is looking exactly like this formula, the formula like this. So minus into minus will become plus, this s outside, 1 by s outside. The remaining part is x of t into e power minus st dt. It is looking like exactly like capital X of s. Now if you look at this part, e power minus s infinity, is 0, and this part is integration from 0 to 0. Limits are 0 width, which means you are trying to find the area from 0 to 0 itself. So width is 0, so area should be also 0. So the Laplace transform of 0 to t x of tau d tau is 1 by s into capital X of s. So that is what we have written previously. Now let us find the Laplace transform for minus infinity to t x of tau d tau. Minus infinity to t x of tau d tau unilateral Laplace transform is equal to, we're supposed to find this. So let us rewrite this as minus infinity to 0 x of tau d tau plus 0 to t x of tau d tau. Let us understand like this, unilateral Laplace transform. Let us find it like this. So once we divide it like this, we know the Laplace transform of this one. Just now we derived it. Laplace transform of integration from 0 to t x of tau d tau, we know it already. Let us write the second part. We know the answer for the second part. It is x of s divided by s. Okay. I don't know if it is visible. So the answer for the second part is x of s divided by s. Just in the previous slide we have derived this part. In the first part, what is it? Is it a signal, constant signal, or some variable signal? So if you look at this one, upper limit and lower limit are constants. Whenever the limits are constant, the derivation of the integration of the signal within constant limits, upper limit and lower limit, if there is no variable in the limits, then this results in a constant. This is a constant. Okay. So unilateral Laplace transform of a constant is always constant times 1 by s. Unilateral Laplace transform of a constant is constant times 1 by s. So just what is the constant? Since we don't know what is the signal, we have to write the signal as it is. We have to write that constant as it is. So that constant is minus infinity to 0, x of tau d tau itself is the constant, and divided by s plus x of s divided by s. I'll just give you an example. What is a bilateral Laplace transform of 1? It does not exist. What is a unilateral Laplace transform of 1? You can find it as bilateral Laplace transform of 1 into, multiply the signal with u of t to find the bilateral Laplace transform. Now it is bilateral Laplace transform of u of t same as unilateral Laplace transform of constant signal, which is 1 divided by s. Here it is constant, some constant a, let's say unilateral Laplace transform of a constant A is A divided by S. So unilateral Laplace transform of this constant is that constant times 1 by S. So this is the property for unilateral Laplace transform if the limits are from minus infinity to small t. If the limits are from 0 to t, then exactly this is the answer. Now let us solve this question. Since they are asking from 0 to t only, so 0 to t only, you can say that it is option B. Okay. Right. So I've recollected whatever basics are necessary to solve the previous year questions. If you want to learn the complete concepts, so you can definitely come on to Unacademy platform and learn from us in a detailed manner. So I'll tell you some details also. Yeah. So with this, in this topic, I've covered the previous year questions on unilateral Laplace transforms and inverse Laplace transforms. So I've given the necessary concepts also to solve the previous year questions. I've not covered all the concepts of unilateral Laplace transform and inverse Laplace transform, but I've covered what is required for solving the previous year questions and a little extra concepts also. So if you want to learn completely, then you can come on to Unacademy platform and learn from us. So if you want to learn completely from us, then you should be taking subscription, Unacademy Plus subscription. I'll tell you the advantages of subscription quickly. Okay. So this is my profile. So I've done my master's from IIT Madras, and I teach these two subjects, signals and systems and communication systems. And yeah, so if you want to learn from me any of these two subjects or both the subjects, you can take subscription on Unacademy platform and attend my classes. Next, let me give you some more details. So you can follow me on Unacademy page. So if you don't have Unacademy app, you can download it on mobile phone and you can use it. Or if you are accessing it on computer, then you don't need to install any app. You can directly access unacademy.com. Yeah, you can follow me on my page on Unacademy to get updates on my classes. Next, so these are all the courses that I've taken on Unacademy platform. So all those courses I've taken live courses only, but they are all available on in recorded format. So you can access any course at any point of time and any number of times. And once you take subscription, you are not only eligible to attend my classes, but you can attend the classes of every expert that is available on the platform. There are extraordinary people available on the platform. So I'm showing some faces here. Apart from these people, there are many other excellent people as well. So for ECE especially, the team is extraordinary. So the team here on Unacademy platform is better than any other team in the country or from any other institute. I can assure you on that. Next. So coming to the subscription fees is very, very less. So the quality that we give is better than the best offline coaching centers in the country. And the fees that we charge here is only 1/3 or 1/4 of the fees that is being charged by the best offline coaching centers. But compared to offline coaching centers, we are having lots and lots of advantages. And the advantages, simple examples I'll tell you. So we conduct every week on whatever subjects we are teaching. Every week we conduct exam on whatever topics we have covered in that week. Let's say every day we are conduct 2-hour classes. So Monday to Friday or Monday to Saturday we take around 10 to 12 hour classes. Every day 2 hours. So on Saturday we conduct an exam on whatever topics we have covered. So which means one chapter or two chapters will be covered in that week, and exam will be conducted on those chapters. We ourselves will prepare the question papers. So that is an added advantage. So offline coaching centers will do nothing like that. And secondly, so if you are not able to understand anything in an offline coaching institute, there is nobody to help you, or you cannot change the teacher also for yourself, right? But on Unacademy platform, there are multiple teachers for the same subject. So if you are not able to follow one faculty, you can attend the classes of some other faculty as well. That advantage is there. And so if at all in offline classes, if you don't understand a particular topic, you cannot attend the class once again, because you'll not be having time, as well as that facility will not be there. Whereas on an online platform, on an academic platform, if you are not understanding that particular concept that well, then what you can do is you can watch the recording once again. So you can watch the recordings as many number of times as you want. There is no limitations. It's unlimited access. And if you want to take subscription, you can use this code. This is my code. So if you use this code, the advantage is you'll get some extra discount. Already the fees is very less. On top of that, you'll get some extra discount if you can use this code while taking subscription. So you can note down this code. If at all If you're taking subscription in any future point of time, you can use this code. Okay, so you can use this code if you're taking subscription for some other category also, like IIT JEE or NEET or any other category also. You can use this code for getting discount. Right? You can take subscription for any number of months, 1 month, 3 months, 6 months, 12 months, 2 years also you can take. So based on your requirement, so you take the subscription for the number of months that is suitable for you. Okay, and one more important thing is the EMI facility is also available. So you can pay the fees, that fees. Let's say you're taking one year subscription. So you can pay this fees in equal monthly installments of 6 months or 1 year. So maybe every month 2000 or 4000. You can pay it in equal monthly installments as well. That facility is also available. Right. So I'll give you my contact details as well. So this is my Telegram ID. So you can contact me on this Telegram ID for any further any doubts you have or anything you want to ask me. You can contact me on this Telegram ID. And this is the group that I'm maintaining on Telegram for clearing doubts of students in signals and communications, the subjects that I'm good at. So I'll be clearing the doubts in those subjects in this group. So you can post the questions in this group whenever you have a doubt. Okay, fine then. Have a good day. Thank you. We'll meet again soon.